write this. So when the absolute value of x is less than 1, the power series, the sum as n goes from 0 to infinity of x to the n converges, and the sum is what? What is the sum? 1 over 1 minus x. And I used a over 1 minus r. So yesterday, I kind of took this very problem in this graphing calculator and I flipped it. I said, okay, now suppose I'm going to start with this function, 1 over 1 minus x, and I'd like to represent this function as a power series if that is possible. So with power series, we're doing this. With power series, we're kind of reversing. You know, in previous part of the chapter, you were given power series, does it converge or diverge, support your answer. Now, you'll be given, and I'm thinking about the 3 sections together, you might be given, like in section 11.10, you might be given a function and you might be asked to find the power series. And in 11.9 you'll be asked to do that. With a power series, so we are given a function like f of x is 1 over 1 minus x, and we are asked to find a power series representation of this function. Now, as far as 11.8 goes, they're not quite here yet. This is what we're going to kind of work towards. And I should maybe, you know, put in a little disclaimer here. If the power series representation exists. So let me put that. If there is one. Now for this particular function, we did this yesterday. In the graphing calculator, I put in, I'm going to call this an example. I put in y1, 1 over 1 minus x. I'm going to graph that maybe on the side here, or maybe on a new piece of paper. 1 over 1 minus x. I know this is a rational function. It's something that you probably studied in algebra at some point. Maybe even last semester in 1552. So let's graph f of x or y. I called it y1 because that's what it is in the graphing calculator. This is a rational function. There is a vertical asymptote, and it's where? It's at 1. How do you know that? That's where the denominator is 0. So I'll put in, I'll try to maybe space this out a little bit. 1, 2, 3. Okay, -1, -2, -3. So there's a vertical asymptote at 1. Is there a horizontal asymptote? Yes, it is the x-axis. How do you know that? The degree of the numerator smaller than the degree of the denominator. And I guess we could pick some points. If I pick 0, I'm going to get 1. I can't pick positive 1. If I pick negative 1, I'm going to get 1 minus negative 1 is 2, so I'm going to get 1/2. Oh, that's not in the right place. Put it right there. So ignore that point. If I put in negative 2, I'll get negative 1/3. And this graph is going to do this. And then on the other side, if I put in like 2, I'll get negative 1. On the other side, I'll get this. So that's the graph of 1 over 1 minus x. Now when we're looking at power series, we're looking at this infinite polynomial. And what I did in the graphing calculator yesterday, let's see if they're still in here. Some of them. Can I clear what you have? Okay. I'm just going to clear that one because and we'll clean that one up. Okay. So in y1, I'm going to put 1 divided by 1 minus x. I'm going to set the window -5 to 5 and on both the x and the y. And so I'll hit the graph. Let me graph the first 3. I'm going to turn this one off and that one off. Okay, I'll hit graph. So there's the one I just graphed for you. There's, oh, I put in the wrong line. Okay, let's fix that. So y2 should be 1 plus x. 1 plus x. And then here's my 1 over 1, there's my 1 plus x. Here's y3. And that's all I graphed. So the point being this, with power series, as I put in terms, remember the power series is an infinite polynomial, but even if I just look at a few terms, y2 is this line. Well, there's that extra point. It's on this line. That's y2 is 1 plus x. And then y3 is a parabola. I'm not gonna try to find the vertex, but the parabola does something like this. As far as an estimate of f of x, as I'm close to this point here, the point that's 0, 1, then these graphs are a pretty good approximation for my function f of x. When you took 1550, they did do things like you did equations of tangent lines. That's what y number 2 is. It's the equation of the tangent line at this point. Y sub 3 gives me this parabola that's even better approximation than the tangent line. Y sub 4, which I've turned off, I'm going to turn it back on, is an even better approximation than the parabola. And of course, with the power series, let me go back to negative 1.5 to 1.5. With the power series, it's an infinite polynomial type function. So it's a pretty good approximation. Now, what's happening though is this function is only equal to this sum when what? When the absolute value of x is less than 1. It's only good in that region, for those values of x. Outside of that, it's kind of nonsense. So power series is taking a function and looking to see if we can represent